Hi, everybody. I wanted to give you a visualization of the function transformations that we just learned in the last lecture. So if you look at your screen here, what you see the function y is equal to x squared. And you saw that on the board before. We'll do a couple of other ones as well. But let's start with x squared so you can see how these transformations can be applied to them visually like this. So let's look at the second function here. If there's a plus outside or a minus, that's a vertical transformation, a vertical shift. So we need to either move it up or down. And as you recall, the plus means up and the minus means down. So if we could take a guess right now, what would the graph look like if we wanted to do x squared plus 2? Well, we know that this point needs to move up 2 to here, and all these other points just move up 2. So this point would be here. This one needs to go up 2, so that would be here. And so let's take a look. So as you can see, we have this second graph, which is the red one, and the red one is x squared plus 2. So it does, in fact, shift the graph up, and it moves each point up by 2. Notice this one, if I move it up 2, I'm right at the graph. This one, if I move it up 2, I'm right at the graph. So it just shifts everything up for you. Let's take that one away, and let's look at one where it has the minus or plus inside the parentheses. So look at this one here, minus or plus inside the parentheses. Remember, when it's a minus, it moves to the right, and when it is a plus, it moves to the left. So if we look here, we're going to take a guess. We would say, okay, we need to take this point and move it to the right 4, right here. That's where it needs to go. It needs to go right in this spot. And all these other points, of course, will as well shift over 4. Let's take a look at what it looks like. As you can see, I've turned on the graph, and it's the exact same graph as this, except it's shifted over 4 to the right. These are vertical and horizontal shifts. Let's take a look at this with another function. Okay, so now what we have here is the absolute value of x function. It's a base function. It looks like this, and we can kind of look around. It's just kind of a V shape. The same thing would apply here. Look at this plus 2. The plus 2 is outside of the absolute value. So in that case, it's going to shift it up by 2, just like so. Notice every point on the graph has moved up 2. That's a vertical transformation. Looking at the horizontal transformation, this one says plus 3 inside. See, it's inside, affecting the x. So in this case, it's going to move it to the left by 3. Remember, plus is left when it comes to horizontal. As you can see, when I turn that graph on, it has moved all these points over to the left by 3. Let's take a look at combining these together. In this particular example, what we have is the quantity x minus 2, the absolute value of that, and that's all subtracted by 1. Remember, the outside is the one that deals with the vertical shift, and it's a minus 1. So we're going to move down, the whole graph is going to move down by 1. Once that's done, it's going to apply the horizontal shift as well. And remember, that's the minus means right. So this graph from the original position needs to be down 1 and right by 2. We can take a look at this point here. If we move it down 1 and then we move it to the right by 2, this is where that point should be at this particular time with this graph. So this point should go down 1 and right by 2. And in fact, all these points are going to go down 1 and right by 2. This one's going to go down 1 here and right by 2. So it'll be right here. Let's take a look. This is what it looks like. As you can see, here's the first point here. I've gone down 1 and to the right by 2. So that's how vertical and horizontal shifting works. I think it's a pretty simple concept to understand. So let's move on to the next one, which deals with reflection. All right, if we take a look at this one, you look at this function here, I have the absolute value, which is green. That's the base function again. And we're going to just reflect it. Notice how when the negative sign is outside of the function, that means it reflects on the x-axis. Let's take a look. See how now the purple one is now a mirror image, kind of as if I folded it over the x-axis. Now let's look at it if we change it into this. Let's take this and instead put it here. Now look what happens. Well, it's the same function itself. It's just folded over the y-axis because now it's inside of here. But if we turn this off and we look, this is a symmetrical graph. So technically, if I fold it around the axis, rotate it around the axis, then I'm going to get back the same exact graph. However, let's take a look at one that would be different. Okay, so now what we have here is we have the function square root of x. This is the square root of x function. And look what we have. We have two examples using this reflection. We have the negative, which is outside, and when we have the negative, which is inside. When it's outside like this, it means it's going to reflect on the x-axis like so. See, it's going to reflect on the x-axis like this. Now, if you take a look here, what's happened is we've just kind of folded it around and rotated it directly around the x-axis, okay? Let's turn this one off, though, and look what happens when the negative's on the inside. Notice that it reflects around this axis now. So those are the difference in terms of the reflections. Now let's look at shrinking and stretching of functions. Okay, what we have here is, again, the base function of x squared. Let's take a look at some stretching and shrinking when it comes to transformations. Notice that when the number is a 4, which is greater than 1, we recall that means we're going to stretch it. Stretching vertically, meaning like if we had a rubber band, we pull it straight up, and it would kind of get skinnier in the middle. Let's take a look. So what's happened here is everything has been stretched vertically by a factor of 4. Let's take a look at it when it's a fraction instead that's in front, something below 1. See how the orange one now, it's been shrunk, so it kind of squeezes out. So that's the effect of shrinking and stretching. Now let's take the base function and apply all of the things together to see what we get. Okay, let's take a look at this. We're starting with x squared, and what we need to do is we need to figure out what's going to happen to this, what transformations do we need to apply to get to this particular graph here. -3 times quantity x minus 1 squared plus 3. Well, the first thing we know is this graph is going to move up 3. Okay, so let's actually take this point. Let's start at 0, 0. So here's point A. Let's take this point and move it according to these transformations that we have. First off, we see that we need to move this point up by 3. So let's do that. Okay, so now you see that A has now been shifted up by 3. So that's good. We're good to go there. Next, we notice that this is a -1 inside here, which we know that means that we need to move it to the right by 1. So let's move that point to the right. Okay, so now this is where we're at. At this point, we know this is where this point's going to end, and let's see what happens. We moved it up 3, we moved it to the right 1. This negative sign means it's going to flip and be downward facing, and this 3 now means that it's going to be stretched, so it's kind of skinnier looking. So this is, it should be at this point. Let's check and see. There it is. So now you can see that we've been able to move the graph. It has flipped down and it looks a little bit skinnier. So hopefully this gave you a little bit of a better understanding of the transformations of functions. It's a pretty straightforward topic, but it's always good to see it visually. Okay, I'll see you guys next time.